So I'm going to take my own advice, and I'm going to read this problem again. It says, find the length of an arc of a circle of radius 12 inches that is intercepted by a central angle of 60 degrees. So first off, let's draw something. Okay. Here's a circle, which I'm going to use just as a structure to put things in. I know, first off, 60 degrees, I have to go into radians, right? Actually, what am I still finding arc length? Yes, I'm finding the length of an arc. Here's 90 degrees, here's 45. I'm just going to make this up. This is like about 60 degrees, something like that. I was told that this radius is 12 inches. And they want me to figure out this arc length. So here's the deal. I know that S is equal to theta times R. However, this has to be in radians. And this is another good thing to know. How many radians is 60 degrees? This shows up all the time. And how do you do the calculation? Well, you know that 60 degrees times, I want to multiply it by the unity factor and come out with radians. I want radians left over, so it's going to be pi radians divided by 180 degrees. The degrees cancel. This is 60 over 180. Oops, that looks like 66. Pi, this is pi over 3. This is a very good thing to know, which I'll put in red. 60 degrees is equal to pi over 3. 120 degrees is equal to 2 pi over 3. And obviously 180 degrees is 3 pi over 3, which is just pi. There is this base that you need to memorize and really get to be successful at this. And sometimes some people don't think that's the greatest fun in the world. And how do you memorize stuff? You memorize stuff by writing it down. I'm going to create a list for you of stuff that I think you should have in your memory, and you should write it down every day. I do this. I did this all the way through graduate school, including memorizing theorems. When I sit down at my breakfast table in the morning and I eat cereal, I have something to copy down. So I'm eating cereal and I'm memorizing stuff. How can you tell when you memorize stuff? When the sheet of paper that you had stuff to memorize on, you turn it over and you write up a piece of paper. You may think that this is a little bit obnoxious, but think about what you had to do to learn the language you speak, whether it is Ubik and Upiak, this probably won't get that far north, or English. I mean, your multiplication tables, just committing basic facts to memory is an important part of what you're going to be doing. And once again, I'll clean the board, and we're probably at our time limit for this one. The area of a wedge segment, of a pi segment, we know that the area of a circle with radius r, the area of this is pi r squared. Hopefully everybody knows that. If you don't, you definitely want to soon. What is the area of a segment here? Well, actually, to prove this, you need calculus, which all of you will probably be doing next time. I think I proved this about in Cal 1, Cal 2 for sure. In general, and this is another one of those memory things, the area of a wedge, and maybe I'll write this like this, the area of a wedge, this is 1/2 r squared theta. Of course, theta is in radian measured. Let's see what comes out of this. Suppose we have the unit circle. R is equal to 1. What is the area of this whole circle? It is pi times 1 squared. This is just pi, okay? Let's see if this formula works, at least. How many degrees does this have? Well, 360, but I'm talking about radian now. So there's 2, so theta is 2 pi here. R is equal to 1, so the area of this, a very large wedge, the whole thing, should be 1/2 r squared, which is 1 squared, times 2 pi. The 1 just multiplies through, nothing happens. This is equal to 2 over 2 pi. This is pi, which it is right here. So you can see that, at least in one instance, this formula shows true. If you did it with quarters of sections, it will come out. The truth is, this is the correct formula, and you can probably argue this out with proportions, but you can't really prove this until calculus.
you have to know this. Sorry, that's just kind of the way that it is. Let us do another one of the kinds of problems you're going to be asked for your homework when you finally get there, when your books come. And I guess I'll do it up over here. In a circle of radius 5 feet, find the area of a sector, and incidentally a wedge is called a sector, with central angle 45 degrees. So first I'm going to draw a picture as good as I can. Central angle is 45 degrees. This is one of those things, so here's what they're asking for. This is one of those times when it really helps to know that 45 degrees is equal to pi over 4 radians. And this, I mean, this is just one of these things that shows up so much you want to know this. Let's use this formula. An R is equal to, I already forgot, and I'm holding it in my hands, 5 feet. So according to this formula, the area of this sector, of this segment, is going to be 1/2 r squared, which is 5 squared, times pi over 4. This looks like 25/8 pi. Okay, so now, and I'll write this down, 9.8175 foot squared. This has, remember, area is squared something in length. This is, okay, so I'll write this like this. Which of these is better? If you're in a physics class, they're going to want you to use something like this. Physicists and any practical math class are going to need something like this. As far as I'm going, this is an absolutely perfectly lovely number right here. Because of the way this course is set up, you're primarily just going to be graded on your tests, and I haven't really figured out how I'm going to do it yet. But if you wanted to leave this answer, I would think this is totally fine. There are other professors who would not like that, and one of the pains that you have to deal with is figuring out what your professor wants. I'll try and be as straightforward as I can. To me, this shows that you know what's going on. I want to talk about one more thing for about 5 minutes, and then you guys will get to move on. And hopefully your books will be coming soon, and we'll get you moving in this. And let me get some. I want to think about velocity, and one thing in particular this book doesn't describe very well is what's the difference between speed and velocity and angular velocity. A very important notion of speed, and here's a problem. Usually, you've probably seen it, speed equals distance divided by time. Why is this going to be a really bad notation for here? Because we're already using s as arc length. So what we're going to do is we're going to call this velocity. However, velocity, speed is a scalar. Speed is a number. When you say somebody's going 60 miles an hour, velocity means there's a direction attached to it. If you say that somebody is going 60 miles an hour northwest, that's a velocity. If you say somebody is going 20 miles an hour south, that's a velocity. If you just say somebody's going 20 miles per hour, that's a scalar speed. It's just telling you how fast they're moving, but it gives no direction. Generally speaking, and we are going to get into vectors in this class, and this is why I think it's a little unfortunate that they were this sloppy. And, why did we use this book? That's a long story. You don't even want to know.